Bismillahirrahmanirrahim. Assalamu alaikum students. Today we are going to discuss another problem. So let me write today's problem. The problem goes like this. In the system shown in figure 1, assume that R12 is equal to R13 is equal to R23 is equal to D is equal to 12 centimeter, and that Q1 is equal to plus Q, Q2 is equal to minus 4Q, and Q3 is equal to plus 2Q, where Q is equal to 150 nanocoulomb. Then problem says what is the potential energy of the system. Let me draw the figure. So figure is like this. Q1, Q2, Q3, R12, R23, and R13. So this is my figure 1. It shows 3-point charges Q1, Q2, Q3. R12 is the distance of separation between Q1 and Q2. R23 is the distance of separation between Q2 and Q3. And R13 is the distance of separation between Q1 and Q3. And the problem says that assume all these three distances R12, R23 and 13 are equal to D equal to 12 centimeter. So all the separation distance are given as 12 centimeter, and Q1 is positively charged particle with charge plus Q. Q2 is having minus Q charge, 4Q charge, and Q3 is having plus 2Q charge, while Q is 150 nanocoulomb. Remember, 1 nanocoulomb is 10 raised power minus 9 coulomb. Now we have to find the potential energy. Of course, it is electric potential energy of this system of charges. In the last lecture, we discussed this expression. We said if we have two point charges Q1, Q2, separated by distance r, then the electric potential energy of this 2-point charge system is 1 by 4 pi epsilon naught Q1, Q2 by r. Epsilon naught is the permittivity of free space. Now, in this problem, we have three charges. So, we have to use the same expression for each pair of charges. That means for Q1, Q2, then for Q1, Q3, then for Q2, Q3, then we have to add those three potential energies to get the potential energy of the system. I repeat, we have to use this expression for each pair of charges and add the resulting potential energies of each three pairs to get the potential energy of the system shown in figure 1. Right? So let us do that. So I can write the potential energy of the system as 1 by 4 pi epsilon naught plus Q times minus 4Q over D, then plus Q times plus 2Q over D, then plus minus 4Q times plus 2Q over D. Let me show you the figure first. Remember, Q1 is, let me use some other color, this one. Q1 is plus Q. So this is my plus Q. Q2 is minus 4Q. And Q3 is plus 2Q. Right? Q3 plus 2Q, Q2 minus 4Q, and Q1 plus Q. And all these three distances are equal to D. Right? So we are using this expression for each pair. I have taken 1 by 4 pi epsilon naught common. Then my one pair is plus Q minus 4Q over D. That is this one, plus Q and minus 4Q. That is Q1, Q2 pair. Then second pair is plus Q plus 2Q over D. That is Q1, Q3 pair. Then third term belongs to minus 4Q plus 2Q over D. That is Q2, Q3 pair plus 2Q times minus 4Q, right? So when we simplify this, It turns out to be minus 10 q square over 4 pi epsilon naught d. So let us put the numbers. Minus 1 by 4 pi epsilon naught is 8.99 into 10 raised power 9 Newton meter square per coulomb square. Then there is 10. Then I have q square, and q is 150 nanocoulomb, is 150 into 10 raised power minus 9 coulomb. Then I have square, right? And d is 12 centimeters, right? D is 12 centimeter, which I convert into meter, that is 0.12 meter. Let me check it. It is minus 10 q square over 4 pi epsilon naught d, and is minus 8.99 times 10 raised by 9 Newton meter square per coulomb square. There is a value of 1 by 4 pi epsilon naught. Then I have 10. Then I have q square, where q is 150 into 10 raised by minus 9 coulomb. Then I have a square outside, and there is distance downstairs 0.12 meter. So when you make the calculation, it turns out to be minus 1.7 into 10 raised power minus 2 joule. I can write it as minus 17 millijoule. Remember, 1 millijoule is 10 raised power minus 3 joule. So this is the potential energy of the system of charges shown in figure 1, right? Minus 1.2 into 10 raised power minus 2 joule, or minus 17 millijoule. As always, check the calculation at home. Now, there is an interpretation, let me write, of the electric potential energy of a system of point charges. That interpretation is this way. The electric potential energy of a system of fixed point charges is equal to the work that must be done by an external agent to assemble the system, bringing each charge in from an infinite distance. The charges are at rest in their initial positions and in their final positions. The electric potential energy of a system of fixed point charges is equal to the work that must be done by an external agent to assemble the system, bringing each charge in from an infinite distance. The charges are at rest in their initial positions and in their final position. This is the interpretation of electric potential energy of a system. I hope you know it. I'm just refreshing your memory. So when we calculated this electric potential energy of the system as minus 17 millijoule, making use of this expression, this is basically the work done by an external agent to assemble this system of charges in figure 1, right? And in this interpretation, it is assumed that initially and finally charges are at rest, and they were assembled from infinite distance to this particular configuration. That means if initially is the initial configuration Q1, Q2, Q3, all at rest and at infinite distance from each other, right? So initially if they are this way, at infinite distance from each other and at rest, now the final configuration is what is shown in figure 1, this one. One is upstairs, 1, 2, 3. This is Q1, this is Q2, this is Q3, this is our R12, this is our R23, and this is our R13, R12, 2, 3, 1, 3, right? And in this final configuration, all the charges are at rest. Now the external agent needs to put minus 17 millijoule of work, minus 17 millijoule of work to change this configuration from initial to final, right? This is the meaning of this potential energy of a system of point charges. fixed point charges. I have 3 charges at rest at infinite distance from each other. Now external agent changes this configuration and assembles the system as shown in the figure 1, and they are assumed at rest. Finally, also, now the potential energy of the system of charges is the work that external agent needs to put in to change this configuration from initial to final, right? I hope it is clear to you. I solved the problem, but I thought I should make this point about the interpretation of potential energy. So I hope you enjoyed this problem. This is all for today. Don't forget to like, share, and subscribe my channel. You can give comment in the comment box. Thank you. God bless you. Assalamu alaikum.